Hello, everyone, and welcome to Talk Nerdy. Today is Monday, September 26th, 2022, and I'm the host of the show, Cara Santa Maria. And as always, before we dive into this week's episode, I do want to thank those of you who make Talk Nerdy possible week after week. Remember, Talk Nerdy is and will always be 100% free to download, and that is because we rely on the support of listeners just like you. If you'd like to pledge your support on an episodic basis, all you've got to do is visit patreon.com/talknerdy, where you can learn about all the perks that come along with your support. I do want to thank this week's top patrons. They include Daniel Lang, David J.E. Smith, Mary Neva, Brian Holden, David Compton, Dudas Infinitas, Gabriel F. Jaramillo Gonzalez, Joe Wilkinson, Leonard Prince, Pasquale Gelati, Patrick Flynn, and Ulrika Hagman. Thank you all so much. All right. Let's dive into this week's episode, which I actually recorded quite some time ago, but I had kind of a hard time with editing on, so it's taken a bit because it sort of fell at the same time when I was traveling across the country and starting my internship. And it's been a lot, but I'm really excited to finally be sharing this episode with you. So I got to interview two different incredible women. First, it was Dr. Virginia Louise Trimble. She is an American astronomer that specializes in the structure and evolution of stars and galaxies. She also focuses on the history of astronomy, and she really is a trailblazing woman in the field. We're going to talk quite a bit about that when during the episode with her. But basically, she was one of the very first women to get a PhD from Caltech. She was only the second woman allowed to access the Palomar Observatory. At the time that she got her PhD in 1968, Caltech didn't admit women. They only admitted women, quote, under exceptional circumstances. And she was exceptional enough that they couldn't not give her her degree, which is pretty incredible. So we dive into that. And then afterward, I speak with Dr. Sara Seager. She's a professor of planetary science and physics at MIT. And her research is really all about finding and identifying another Earth. So we talk about exoplanets, we talk about habitable zones, we talk about what we're looking for and how we're looking for it, and some of the really unique approaches that she and her lab are taking to search for other Earths within the universe. This is a good one. So the reason I talk to both of these incredible women is because, one, Dr. Trimble is one of the co-editors of, and two, Dr. Seager is one of the individuals who contributed to a wonderful volume called The Sky is for Everyone, Women Astronomers in Their Own Words. This is an anthology of writings by women who really did trailblaze within astronomy from around the globe, and they all have different passions and different subjects that they focused on and different stories to tell. Again, Dr. Virginia Trimble co-edited this book with David Weintraub, and Dr. Sara Seager is one of the astronomers featured within the book. So without any further ado, here they are, Drs. Trimble and Seager. Well, Virginia, thank you so much for joining me today.
Well, thank you for the invitation.
So I'm super excited to talk about the book that you co-edited that's coming out. By the time this airs, it will have already dropped, but just barely, called The Sky is for Everyone, Women Astronomers in Their Own Words. And of course, you are a woman astronomer, and you were, developing those credentials. You were becoming a woman astronomer at a time when you were probably one of very, very few in your department.
Well, it depends on which department you pick. It's also true that I have written one of the chapters in the book, as well as being co-editor with Dave Weintraub. But Caltech, in its day, did not take women at all for any level of education, and they didn't take undergraduate women until the 1970s. But at the time I applied there, their catalog said women are admitted only under exceptional circumstances. That it usually meant gals who came with husbands, or sometimes with a faculty member who was relocating For what it's worth, I was the first female accepted in astronomy without being part of a package deal with anybody. They weren't sure they wanted me, but it turned out well, I think. I have no complaints, and if they have complaints, it's too late.
What was the process like when you applied then? Were there a lot of hoops you had to jump through?
Well, there was a difficult medical examination because it assumed the medical properties of a young gentleman. And there were several things that the doctor just had to leave blank. He couldn't really answer the condition of my prostate and things like that. But we did have to have tuberculosis test and a DTP vaccination. Polio vaccination didn't quite exist yet, but I had a mild case in childhood, and I've never gotten it again.
Oh, wow. Wow. So you were admitted to Caltech you earned your PhD in 1968. So what year were you admitted?
I started in the fall of 64.
Okay.
I actually went from high school graduation to a PhD in 7 years and 3 months. Students don't do that anymore, and I'm not quite sure why. The title of my thesis, you're going to love this, nothing sounds sillier than the technical title of a paper in somebody else's field. Motions and structure of the filamentary envelope of the Crab Nebula.
Ooh, filamentary envelope.
The Crab Nebula is a remnant of a supernova explosion. The light reached Earth in 1054. The gas started expanding from the explosion. And somebody in the 1920s recognized that expanding cloud probably had started around 1054. And by the time I came into the picture in the 60s, there was a large-style stack of glass plates of images of the Crab Nebula, most taken by Walter Baade, some later ones taken by my thesis advisor to keep up a long sequence for studies of how things had changed, hence the motions and structure of the filamentary envelope. And I learned when the explosion had happened, how much energy was involved, which was interesting. That at the time we started, it was not clear what kept up the energy. And the discovery of pulsars and the pulsar in the Crab Nebula answered that question, what kept up the energy? And yes, I know Jocelyn Bell Burnell, and we met when we were both still just barely postdocs. We've been friends ever since.
Where was she studying?
Oh, she did her PhD in Cambridge. She was the one who found the traces in paper tape records, this is a long time ago, of the little beeps that were indeed the emission from pulsars. She was the student of Anthony Hewish, who died quite recently, and he was the one who got the Nobel Prize. And at the time, she said she didn't object to this. On the other hand, she has said later that she knew she would need recommendations from her thesis advisor in order to get jobs, and so she didn't really want to quarrel with him.
That's not an uncommon story, is it, for women, especially, I mean, even today, but especially many decades ago, for women who did the majority of the work on specific investigations to not be recognized?
Yes and no. I mean, the classic case, of course, is the discovery of the period luminosity relationship for Cepheid variables, now called Leavitt's law for Henrietta Swan Leavitt, who indeed undoubtedly made the discovery looking at images of the Magellanic Clouds and looking at the stars in the Magellanic Clouds, nearby galaxies, whose brightness varied periodically. And it was she who discovered that the brighter the star was, the longer its period of variability. This is still used as part of the distance ladder to get us out to cosmological distances to try to understand the universe as a whole. And actually, one paper was published just under her name. The second paper was published by the director Pickering, who says in the first paragraph that all the work was done by her. Let me say, all the heavy lifting was undoubtedly done by David Weintraub. He was a great guy.
And the women who wrote for the book, how did you and David go about selecting them and, focusing in on where their chapters did focus?
He already had a group of probably a dozen women who agreed to write when he and Princeton University Press first discussed the issue. When I came on board, I thought in terms of filling in a number of things, nationalities of the authors. We did fairly well on that. We have a couple of people from India, one from Japan, one from China, and so forth. Filling in nationalities, subdisciplines to pick up infrared and radio astronomy, generations to make sure that we picked up the earliest we could get. Unfortunately, one of our authors died just before the book came out, Judith Pfeiffer, and down to the present time. I tried to fill in some gender issues on ethnic minorities. Yes, we have a couple of Black astronomers, both fairly young, because until fairly recently, there weren't a lot of Black women astronomers.
Yeah, so part of the problem with representation when trying to put together a book like this is that the field itself resisted representation for a very long time. There's really no denying. You said yourself at Caltech, they weren't even admitting women until the 70s.
Princeton took even longer. I mean, once upon a time, long ago, universities existed to educate men for the clergy. And in Catholic countries, that definitely meant they had to be men. Realistically, in Protestant countries, the clergy were all men, not quite by law of the church, but by custom until, again, rather recently. And so if your primary task is to educate clergymen and advanced teachers who are also men, what would you want women students for?
Right, but of course.
Until we broke down the doors asking.
Exactly. I mean, and fighting very often, I don't think there was, I don't think a polite, how about me as well, was really going to cut it for some of these institutions.
Possibly not. I mean, all the real barriers fell just ahead of me. I was the second woman to get observing time at Palomar under my own name. The first was Vera Rubin, whom we missed very much. There were a couple of women admitted to Caltech before me in other departments. Math was first, actually. And the first math PhD woman was a student of Olga Towsky-Todd, a very distinguished mathematician who did not have a proper job there for years. She'd been hired in a package deal with her husband. And she was undoubtedly the greater mathematician, meaning I don't understand her papers even now. But observing time, graduate admissions, fellowships. I was not the very first woman to get an NSF. I was one of the early ones. But the barriers just fell right ahead of me. And I walked over them.
But you were still in that sort of early stage. Just because one woman might have done something before you doesn't mean that there was parity by any measure. And I think that's really what we're seeing still today, although there are many, many women astronomers. And across kind of most STEM fields, there are many women within these fields. We're still seeing a lack of parity at sort of the highest levels, at administrative levels.
There are places now where women slightly outnumber the men. That's true in college in general. It's true for brand new medical doctors, not in prestigious places like surgery, but in gerontology and family practice. And there was a time when 100% of doctors were men. But people should do the things that they are best at, and not everybody's going to be a great scientist. And my view of equality is just making sure the barriers look as high for white guys as they do for the rest of us.
Right, exactly. Yeah, not everybody is going to be a great scientist, but there's nothing fundamental about our gender that says we will be good or not good at science.
There was unquestionably a time when many places the women did not get topics that were as likely to be hot, neat, new science as the guys did. That was certainly true at Caltech. The first two women who finished never actually even published their PhD dissertations. Mine was published. My thesis advisor had two piles of glass plates of the Crab Nebula, the filamentary envelope, and the continuum synchrotron emission. He divided those plates. I got the envelope. Jeff Scargill got the continuum because Guido thought that the continuum would be more interesting and get better science. It happened he was wrong, and I got the better deal. But that was not his intention. I think we don't do that anymore. I think genuinely our women students, many places, maybe not all, but most places now get thesis topics as interesting and as exciting as the ones the guys get. They're in cosmology, exoplanets, large-scale structure. We have a couple of those gals at the young end of the book who worked on some very exciting topics.
Tell me about some of the women that are in the book. Were there women that, is it safe to assume, I should say, that being a woman in this field, kind of a pioneer in this field, that the the relation, or how do I put this? That the field felt small, that you kind of knew many of your colleagues, even if they were at, universities across the globe, or were many of the women that were featured in this book new individuals to you?
I've met, I think, all but two of them.
Mm-hmm.
One is in South Africa, maybe even working in Zimbabwe or someplace like that now. And the woman from China I have not actually met. I was introduced to her by a younger Chinese colleague whom I did know. Astronomy used to be small. When I went to my first IAU meeting in 1970 in Brighton, England, the total membership of the International Astronomical Union was fewer than 2,000. It's now 19,000 or some number like that. The whole field was small. And yes, mostly everybody knew everybody. But in addition, because there were a few women, people remembered us, and we could get to know anybody we wanted to know.
The women that were featured in the book, is there anybody that you would like to highlight? Anybody who maybe their career goes back quite a long time, or who you really have collaborated with or grown close to over the years?
There are no co-authors there, except maybe on one of these white papers or something where there were 2,000 authors. We happened both to be there. The women I've known best, of course, were the other Caltech gals. Judy Cohen, who's emeritus there now, and Anila Sargent, who's emeritus there now as well. And there are a lot of them I certainly regard as friends. Sylvia Torres Pember in Mexico, Patricia Whitelock from South Africa.
And so tell me a little bit about how we kind of began the conversation with this question, but how these women were chosen to tell their stories. Was it more about breadth? Was it more about depth? Was it about covering multiple topics within the field of astronomy? How did you kind of choose what order to go in and what stories to tell?
There was a great deal of randomness. I mean, again, David Weintraub started with a group that had already agreed to help, and I think they all did chapters. I first thought of my friends and asked my friends. I've always done that, and that's why if you want a lot of women speakers at a conference, you should have women on the organizing committee.
Absolutely.
If you want women to be officers of your society, you should have women on your nominating committee. I once did a bunch of, quote, volunteering of my colleagues for something. International Union of Pure and Applied Physics. They needed people to fill in a bunch of tasks. And I was asked, do I know somebody in Lithuania? Yeah, Grażyna. Do I know someone in Poland? Yeah, Bożena. In other words, the people I put forward were all other women. And when the group got together, the president, who should remain a nameless, but he says, too many women.
Yeah, of course.
We were half.
And half is too many. Yeah.
Half is too many, yeah. He's no longer with us, so I won't ask whether he might have changed his opinion. But I asked my friends. And when they didn't respond, I went to friends of friends in some cases.
So tell me a little bit about your chapter. How did you go about authoring your chapter, and what did you want to make sure was included?
When they started out, again, David and Princeton University Press had some gals in mind who'd already agreed. And somebody said, and I think it was actually Princeton University Press, well, Virginia, why don't you write a sample chapter and we can send it around as an example to women who are coming on board. So I sat down, and it took one afternoon. I happen to be a good typist. I'm a fairly lousy keyboarder. And it's easy to talk about yourself. You must know that. It's easy to talk about yourself. So I sat down and I wrote the thing in an afternoon. And David decided not to send it to the others, as it would not necessarily provide a good prototype. And indeed, the chapters are very different in where the women start their stories. Some start with being born. Some start, as it were, with a successful career already in place. Some start in the middle. Mine happens to start in the middle. But they have different flavors, not just because the women speak different languages, but because they've had different experiences. But I just wrote mine, not even sure it was going to be used in the end. David and Princeton University Press decided to use my chapter. And I found a nice photograph from when I was a graduate student to illustrate it. But I just started with getting the letter of acceptance from Caltech and the funny way it was phrased. And my mother said, ignore the second sentence, so I did. Then I went back to childhood and forward to jobs and things I've worked on over the years and people I've known over the years. And pretty soon my 3,000 words were up. So I stopped.
And tell me from kind of an overall editing perspective between you and David, what was the hope? What was the goal of presenting this this collection of stories?
We did the absolute minimum of editing consistent with hoping that things would be readable and understandable. A few of the authors have English as their fourth or fifth language. He did, I think, more changes than I wanted to make. In a few cases, a technical term was used and not explained, and we asked, or one of us asked, a paraphrase that would make clear what the technical term was, absolute magnitude, whatever. And we've indexed those as well. But we wanted the voices to be the voices of the authors. Nobody wrote so far too much that it had to be cut. A few people wrote a little less than their quota, and that took care of people writing more than their quota. And PUP let us go over the page limit in the end. So you have a nice index with everybody in it. My theory is everybody mentioned in the index who's still alive is going to want to buy a copy.
And aside from the from sort of the technical aspects of editing, what was the goal? What were you hoping that people who pick up a copy of this book take home with them?
It's been suggested that there should be an academic audience where folks will ask, gee, are we still not doing a good job of editing or educating women and minorities? I had in mind reaching down at least to high school students who might still be debating what they want to do for the first 50 years of their now 100-year lives, and suggesting that science is a possible way to go for people of various genders, various ethnicities, various countries particularly. There's still countries where it's not easy to get an education, never mind what gender or race you are. There are poor countries in the world who can't afford the book, I admit. But I didn't have any very firm goals except, gee, this is fun to do. And I'm glad to talk to these gals that I haven't sometimes seen for years since we were last at an IAU together or something. And I'm glad to know what their lives were like both before and after I knew them well. I was distressed to learn that a couple I knew fairly well had had a more difficult time than I realized. Pleased to learn that some I knew well had just as easy a time as I did.
And what do you hope that
I hope people are going to I hope people will enjoy reading it. And that's what reading is for.
Yeah. What do you hope that if a high school girl picks up a copy of this book, what do you hope that she walks away with, other than obviously knowledge about the field and entertainment?
I would be content to have somebody walk away with one of those two, frankly. Well, I still go through a book a day if somebody else is paying for them.
You read a whole book every day?
On average, yeah.
Wow.
But, most of them are not good. I just reread a Jane Austen. I just reread Northanger Abbey, which was probably her very first written, but her last published. Anyway, again, I would hope that somebody who was debating what to do, maybe not just women, people in general debating what to do, would come away feeling that science and technology, education, mathematics are interesting things to do. They will be changing a lot over anybody's career. The people who are at the beginning of the book did very different kinds of science from what the people at the end did, and different again from what our graduate students starting now are doing, who will have PhDs in 2025 or thereafter. It is an interesting career that it does sometimes help people. That we have that as an issue with women students in physics. They drop out and go into biology or sometimes biophysics or bioengineering because they want to help people. And I think there's no doubt that what happens in physics also affects people's lives a lot, and some of it is good. We would not have all these clever technologies that enable us to communicate if it were not for Hewitt and Packard. My husband knew them both. I did not. And lots of other people who have been scientists and mathematicians. The work done at Bletchley Park, yes, Alan Turing was the famous one, but most of the work was done by young women who went back to being somewhat happier and more employable than they had been before. STEM is an interesting territory. I think it can be a morally satisfying territory, depending a little bit on exactly how you value different aspects of human life, different aspects of life on Earth in general. Do we have anybody working specifically on energy issues? Yes, I think we do. Carol Mundell in England, I think, is in that territory now. There are lots of things that need to be done. Quite a few of them could be done better if you have some background in the sciences. It enables you to be a better judge of what other people say and write and ask you to do. I mean, I'm very glad I did what I did. The Caltech letter of admission said, "We think you might be happier elsewhere." I don't believe it.
Wow. Wow. That was the second sentence?
That was the second sentence, exactly.
Oh,
the first one said, "We've reviewed your credentials and conclude we cannot deny you admission to the California Institute of Technology. However, we think you might be happier elsewhere." And there have been people who were very unhappy there. Some guys as well as some gals. But there are people unhappy pretty much everywhere you look. And if you're somehow making everybody happy, you're probably not offering them as rigorous an education as they are capable of dealing with. There should be a certain amount of hard work and struggle involved.
Well, on that note, Virginia, there's so much more that we could talk about, but of course I can't keep you all day. I'm wondering one last question before I bid you adieu and thank you. Is there anything specific that you feel like we should have touched on that we didn't get to today in our conversation?
Well, I didn't have any idea what this was going to be about. I have been involved in some previous events of similar sort, where sometimes there were three people involved. And you'll find this hard to believe, but the guy got more words in than I did.
I do not find that hard to believe at all.
There's so few of my colleagues that I really don't like, but that is one of them. I will not tell you who that is either. But for the most part, I found good friends. I hope women who come along later in the field are also finding good friends. We're still a community. I think that's important. Most of us teach. Many of us teach, I think. And that's important. And some of us invent clever things. Not me, but other people, other astronomers, and some other women astronomers. And I've enjoyed very much talking with you. And thank you very much.
Thank you so much. Well, Sara, thank you so much for joining me today.
Thanks for having me.
Absolutely. I am excited to talk not just about your work, but also your contribution to the new book, The Sky is for Everyone, Women Astronomers in Their Own Words. And of course, you yourself are an astronomer. So before we even dive into your chapter, I was hoping you could give us a little bit of background on kind of specifically what you studied and how that translated into the work that you're doing now.
Sure. Well, what I studied, do you mean in college or
in graduate school? What was your discipline?
Yeah, well, my discipline.
What are you?
Right. So just to back up a bit, though, like the foundation of astronomy is really math and physics, and also computer science. Mm-hmm. But in graduate school, I actually did study astronomy, and back at that time, that was in the mid 1990s, kind of a long time ago. Something amazing happened. Astronomers first discovered planets around stars other than our sun. So started to discover other solar systems. And, people had wondered about whether or not planets around other stars, other suns exist for literally thousands of years. And at that time in the mid-1990s, astronomers first started detecting them. So while in graduate school, I worked on these brand new planets. And specifically, I studied how to observe and understand the atmospheres of these other worlds.
How, when you were studying astronomy, this discovery was sort of codified like while you were actively in school?
Yes, but I don't know if codified is the right word, because like any brand new discovery, most people were entirely skeptical of it. Because it's actually an amazing example in science. We have our solar system with the rocky planets, Mercury, Venus, Earth, Mars, are kind of close to our sun. And the outer planets, Jupiter, Saturn, Uranus, Neptune, are really far from our sun. And, for like all those, I don't know if it was thousands of years or hundreds of years or decades, people thought they would just find solar system copies. But the first planet found was actually, it was a Jupiter 10 times closer to its star than Mercury is to our sun. It was so completely unexpected. And all the planets that followed, way easier to detect than our solar system, were just so crazy and weird that people pushed back. So although exoplanets, looking back, it was the birth of the field, there was a lot of resistance.
I can imagine. And so I'm so curious about, being in a field where there's this massive discovery that opens up an entire kind of new way to dive into astronomy. It must have been really exciting to say, oh my gosh, there's so much we could study. And so I'm curious how, A, you chose to get into it. Is it that you happened to be in a lab where that's what was going on? Is it that you sought out a lab where that was going on? And B, how did you really narrow in on what aspect of exoplanets you wanted to study?
Wow, those are all great questions, not just for exoplanets and astronomy, but pretty much for any job or personal hobby, right? At the time, we didn't know it was going to be a whole new field, because sometimes new things start, but they dead end because of what nature has in store or because of our technical ability. So at the time, we couldn't say, wow, there's going to be this huge, amazing future in this field. We didn't know our technology could push down. You know how you have a smartphone today and it's, wow, so amazing compared to what, like if you watch TV, I'm watching this show right now. It's called Stranger Things, and it takes place like in the, I want to say 1980s. So back then there were no smartphones, they're just the big bulky telephones. Could they imagine a day when we had smartphones? Like we couldn't imagine that we'd have the technology we needed to do all the great exoplanet work we're doing now, like nearly 30 years after what we're talking about. But back at the time, I was looking for a PhD project because I had finished a master's level project that kind of finished up. And it was actually my thesis advisor who suggested that I work on the new planets. And specifically, he gave me the specific project of studying the atmospheres of the so-called, we called them hot Jupiters, the Jupiter mass planets that were so much closer to their star than Mercury is to our sun. And the question was, what would these atmospheres look like? They're heated so much by their star. What would they be like? And I jumped on this project for two reasons. One is I'm naturally a risk taker and always have been. But secondly, I really wasn't that excited about grad school. I was kind of depressed, actually. I think most people are at some point. And I also had nothing to lose. So while the skeptics were saying, even people on my own thesis committee were saying, why are you studying atmospheres? We'll never be able to detect them. I don't know if this field is going to go anywhere. Like I had nothing to lose. So it worked out for me. And another point I want to make is usually a PhD advisor doesn't give a student such a risky project. It was risky because if the planets didn't turn out to be planets, or if it turned out we could never observe their atmospheres, it wasn't such a hot idea to train someone on.
And so how exactly at this very early stage, how did you guys go about saying, okay, we're going to do some observations and we're going to make some judgments about their actual atmosphere, given that these things are so far away, we can't go to them?
Right. We can't go to them, but we do have telescopes on the ground and in space. And astronomy is built upon remote observations of all kinds of distant objects. Secondly, we have planets in our own solar system, obviously. And fortunately, all the framework like chemistry and physics of atmospheres is and was pretty well developed. So in science, everything we're just building on the last person's things. And so that's how we did it.
Okay. And so I'm curious how it turned out for you, given that it was such a gamble at that time.
I'll tell you what, it turned out absolutely fantastic, beyond my wildest dreams. Now, one thing that happened when I finished my thesis, I went on to do a postdoc. And when you do something new, or if you go to a new place, or you're in a room of scientists that you don't know, it turns out the question everyone asked me, which is a great small talk opener, is, what's the next big thing? What's the next big thing? So people kept asking me that. And I said, you know what? The next big thing in the field at the time, which was around 1999, I said is a transiting planet. It's a special case of an exoplanet when the planet and star are lined up just so the planet goes in front of the star as seen from our viewpoint. I want you to imagine like a dish, like a plate. And if that plate is oriented towards you, like a record, the planet will go in front of the star as seen from your viewpoint. But if you tilt that 90 degrees, and now the plate is like meshed against the plane of the sky, you would never see a transit if the plate, outer edge of the plate, resembles the planet's orbit. So once we did, so I said, we're going to have a transiting planet, we're going to have a transiting planet. And I worked on a brand new idea of mine that when the planet goes in front of the star, some of the starlight can shine through the planet atmosphere. Just like shining a flashlight through a fog. Some light will make it through and some won't. And if we can see, as a function of different colors, what light makes it through and what doesn't, we can tell what the gases are in the planet atmosphere by which gases or which colors are being blocked by the planet atmosphere.
I know that we've measured historically, before we even knew about exoplanets, we measured Venus, for example, by transiting in front of our own sun, right? But did we measure its atmosphere that way, or just?
Well, that's a fantastic question. That's one of the best questions I've ever been asked, because Venus only transits once every 120 years in pairs. So most of us listening aren't going to get to see it again. If you missed it the first time, you still probably won't get to see it. But it turns out, yes, I think it was in the late 1600s or 1700s, astronomers did figure out that Venus has an atmosphere, the first planet other than Earth that people figured out had an atmosphere by something that happened during its transit.
Oh, cool.
So yes, it is something that happened with Venus.
Yeah, so it's a principle that we've utilized, maybe not clearly as sophisticated, we didn't have the tools that were quite as sophisticated back then, but a principle that has been utilized within our own solar system, but now using it to observe things that are very, very far away.
Very far away. And another thing that we build on as well is binary stars, two stars orbiting each other. Eclipsing binary stars are actually very common. And in eclipsing binary stars, people had also used that method. Think of like one star transiting another star. There are a lot of those out there. So we kind of more draw on stars than our solar system planets. But anyway, so I made this study. And right as I was working on this idea, sure enough, the first transiting planet was discovered in the fall of 1999. I had to work so hard to wrap up my paper and get it published before anyone else would think of it. So I got all that done and I made a couple of predictions of what to look for. And some observers took that idea, made a proposal to the Hubble Space Telescope, and soon after discovered the first exoplanet atmosphere observationally. And those two things gave rise to what is today a big field with hundreds of people working on it. And it's a very, very special time in history today because our new telescope, the James Webb Space Telescope, just launched. And as we speak right now, people are working really hard with this brand new super capable telescope to study transiting exoplanet atmospheres.
Oh, I love that. And like when I think back to these first observations that you made, I'm curious, when we think about science and especially things like astronomy, where you said you made these predictions and then observers were able to reinforce that. They were able to actually see the data. I'm curious, does that data continue to become just more and more refined? Are you like, oh, I was right, but look, now there's even more info? Or do you sometimes find that there's something that's like wildly different when we can sort of up the resolution?
Honestly, it's all of the above. When we up the resolution, there are always more questions than answers. I'm sure that's true of a lot of people you talk to or a lot of different fields. Yes, there's always more questions than answers, but at the same time, some of the basics are also confirmed.
Yeah. And so when you look back at your dissertation now, does most of what is in it hold?
Yes.
Good. And then, of course, you continued in this world. So what are you doing now as a professor, as somebody who is actually actively studying on a regular basis?
Well, with my students, we are working on some of the James Webb Space Telescope data and planets, but we do specialize in a field that's still a bit in the future, and that is the search for signs of life on other planets by way of gases in the atmosphere that might be attributed to life. I had a lot of qualifiers in there, but yeah.
It makes sense, though. So the idea is you're using a lot of these same principles to try and understand the atmosphere, to try and understand kind of this chemical signature of I guess maybe spectral signature of the planet. But then based on that, is this compatible with life? What determinations can we make?
Is it compatible with life, or is there even a sign of life? On our planet Earth, we have oxygen in our atmosphere. Like we humans, we need oxygen to survive. But without plants and without photosynthetic bacteria, we would have virtually no oxygen in our atmosphere. It's just phenomenal that life figured out a way to harness energy from the sun by photosynthesis and spit out a waste byproduct gas, oxygen, which today fills our atmosphere to 20% by volume. Can you imagine that when you think plants and bacteria, they've re-engineered our atmosphere and they make oxygen. And almost 100 years ago, an astronomer thought of this. He's like, wow, our atmosphere has so much oxygen. Maybe we could use that as a sign of life on another planet. Even though at the time, he was probably thinking about Venus or Mars or one of our planets.
Right. And and I can't help but think that if there were sufficiently developed civilizations elsewhere, that they might be, stumbling across Earth and taking measurements of Earth in that same way, because our planet is such a candidate. I mean, the thing that that I'm often curious about when I talk to astrobiologists, for example, is of course that telltale question of how important is it to look at our own signatures and apply those to questions about life elsewhere in the cosmos, versus getting very creative and saying, well, but what if they, have a completely different way of respiring, or what if they have a completely different organic chemistry there? Right.
I mean, both of those are incredibly important, because our Earth is our only example, and we should and kind of have beat it to death at some level. But when you think about our Earth, we only had oxygen in what would be visible amounts to an alien civilization for about half of Earth's life, or less even, maybe a fifth of Earth's life. Like we've had oxygen for about half of Earth's life, and it's only been visible for about a fifth of the time. So we also have to think about Earth through time. What did Earth look like a long time ago? And then, yes, we want to get as creative as we can, because we don't have that many planets that are accessible, that are bright enough or near enough for us to study in detail. Wouldn't that be terrible if we had great data on a planet and we just missed it because we weren't creative enough or thinking outside of the box enough?
It also, I think that the first point too that you made about time is such an important one, because it's one of these concepts that I think a lot of us who didn't kind of academically study astronomy still grapple with, this idea that when we look deep into space, we are also looking back in time. Maybe you can help us wrap our minds around that.
I can, sure. Just like, when you throw a ball to someone, or, an object on the water comes closer to you, stuff takes time to travel. And that's also true with light. So if you shined like the most brilliant laser you could out into outer space and hope that it lands on a planet with an alien civilization, they wouldn't see that laser the second you turned it on. That light takes time to travel. Yeah. And so because it takes time to travel, when the signal reaches you, you have to try to understand that that signal isn't from now, but that's from whenever the sender first released it. So in our universe, we have galaxies that are incredibly far away. And we're seeing those galaxies, like an imprint, like a snapshot in time when light was emitted from those galaxies. So it's kind of complicated to get your head around, but any light we see, let's take a concrete example of a nearby object, a nearby star. Let's take our nearest star, Proxima Centauri. It's about 4 light years away. And when we look at that star, and there's a planet around that star, by the way, that might be about Earth's mass, any light there was emitted 4 years ago. So think of your life 4 years ago. If you, like, a lot has happened in 4 years. The whole pandemic has happened. But you wouldn't have that information because the light that you get is only 4 years old. And it's even more from distant places, billions of years old in some cases.
And that's just kind of a core understanding that astronomers, especially observing astronomers or theoretic, astrophysicists too, just have and kind of factor in whenever they're grappling with these questions. How long did it take you for that to feel like a shorthand? Was it something you always just got intuitively, or do you have to constantly remind yourself of that when you're doing your work?
The funny thing is we don't need, I think, as a child, I loved astronomy. And when I became a teenager, I did have like that party phase where I never read a book or anything. But then when I became nerdy, I read so many books. So it was probably then that I grappled with it. But honestly, on a daily basis, when and others presumably are working in astronomy, we don't worry about that. We're not, we don't really think about it because we can't, as you're pointing out, clutter our minds with all the complicated subtleties.
Right.
Like you might say, I'm studying this planet and it's maybe all the light I'm seeing from the star shining through the atmosphere. Maybe that's all 20, 30, 40 years old. But I'm not really that worried.
Yeah. And so now you mentioned that you're doing kind of you're following this line of inquiry, but you're doing it with significantly more powerful and newer tools like the James Webb Space Telescope. Are you asking different kinds of questions as well?
Yes and no. I mean, there are so many types of planets out there. It turned out that our solar system is rare. We don't quite know how rare, but our solar system planets like Earth and Jupiter are very hard to find. So instead, astronomers have found all kinds of crazy planets. One of my favorite, it's a planet that's 2 to 3 times the size of Earth. So it's smaller than Uranus and Neptune, which are 4 times Earth size, but it's bigger than Earth. And it appears to be one of the most common types of planets out there. But we have nothing like it in our solar system. And we don't know what these planets are. We don't know what they're made of. We don't know what they're like. So trying to solve, like some people think they might be water worlds, scaled up versions of Jupiter's icy moons. We don't know. So that there are like probably 100 great questions that I and others are trying to answer. But lately, by the way, I did switch research fields in a way because this search for signs of life elsewhere, now that it's upon us, it's actually probably way harder than anyone imagined. And the reason is because we don't have a lot of information about these planets. They're just not even a point of light, really, And astronomers have got busy concocting various scenarios where you could produce a gas, not by life, but by some other means. So you might champion one gas like methane or oxygen. And then I might say, here are like 5 ways to make oxygen without life. So it became a very complex field, and I still work on this field. It's still like where my heart is in a way, but I got involved with the planet Venus. And this planet is our sister planet. It's kind of like your evil sister in a way, as the surface of Venus it's hot. It's too hot for life of any kind. If we went to the surface of Venus, we would literally die instantly and then melt. But it turns out that just like on Earth, if you hike up a mountain and it gets colder and colder, so too on Venus. And far above the surface of Venus, in the cloud layers, Venus has thick cloud layers that completely cover the entire planet. In those cloud layers, the temperature is just right for life. And here on Earth, we have some life, some bacteria floating around in our clouds. And this thought that comes actually from Carl Sagan over half a century ago that maybe there's life in the Venus clouds. And the reason I got sucked into working on that was a colleague, Professor Jane Greaves, found a biosignature gas in the clouds of Venus using Earth-based telescopes. And that gas, phosphine, we announced the discovery of phosphine gas in the atmosphere of Venus a couple of years ago. It's been incredibly controversial ever since. But after this phosphine announcement, and it has nothing to do with phosphine, my team uncovered a whole bunch of interesting things about Venus, old anomalies, gases, and other things that were kind of shelved and not studied. I convened a team to study what kind of focused missions could we send to Venus to search for signs of life or even life itself. And I've been working on all of that and have a lot of exciting things going on.
Yeah, I mean, Venus is right there. So even though, as you mentioned, there's danger afoot, we're able to send robots to Mars. We're able to, there's the Europa Clipper mission is being developed and in full swing. Like we're able to send probes at least and samples like kind of much farther out in our solar system.
Why haven't you heard about Venus being explored? NASA has not been to Venus for nearly 4 decades. And I always talk about Venus. I think about it like, I don't know if you have siblings, but you know how there's the one sibling who gets all the attention? That would be Mars.
Of course.
Mars would be that one, right? And then there's the one sibling who's kind of always ignored, but perhaps has something very special to offer the world. And that's Venus.
How exciting.
I know. And it's so unbelievable. It's hard for me to even articulate in words because there's almost like a quiet revolution going on right now. And it centers around the cloud droplets because all life needs some kind of liquid. A liquid solvent so that molecules can come apart and react and create new molecules, a biochemistry, for example, if you will. But the clouds in Venus, they're not made of water. They're made of an incredibly harsh chemical, sulfuric acid. And this is a really nasty chemical. Like if you put it on your skin, it would burn a hole. You don't want to get anywhere near this. And it's horrible, really. And so the paradigm has been that it's no life could survive. Certainly none of our life could. Like one summer, that pandemic summer when there were, for kids or teenagers, there were no jobs. The sports fields were closed. There were no sports. My then 17-year-old son, he was working on this project on Venus and he pushed to do some real experiments outside because we don't have a real lab at home. And if you're a 17-year-old boy and you get sulfuric acid and you're testing various things in it, what's the first thing you would do? I mean, you and I were not a teenage boy, but it turns out if you're looking around your front porch, you would grab an ant and put that in sulfuric acid. And the ant immediately had a seizure and turned to a brown goo. And that's what happens to our Earth life. I know, it's so terrible. That was mean, very mean. But the next thing he tried was like a waxy leaf, a rhododendron leaf. And the wax actually was quite protective. And it turns out there's a lot of chemicals that survive in sulfuric acid, graphite, sulfur itself, wax. And we're starting to learn that even some very complicated chemicals, ringed molecules, organic compounds, and a team that's related to mine have found that if they seed sulfuric acid with a simple organic molecule, a rich hydrocarbon chemistry evolves. And so although I don't have any conclusions for you right now, we're on the verge of being able to say, not that there's life on Venus, but we're on the verge of being able to say, in these droplets, a rich chemistry can actually happen. And some of our biochemicals, maybe it's a small set, can actually survive.
That's so cool. And when you say we, are you referring to your lab? Are you collaborating with other labs? How large of a project is this?
It's a pretty large project. When I say we, I primarily mean a team of scientists and engineers I'm leading. We call ourselves the Venus Life Finder mission. And that we has that. Several, I'm glad you love it because a lot of people hate it. Yeah. It's taboo.
What?
It's it's totally taboo to think of searching for life on Venus. And people from NASA to potential private financial donors, they resist that term so bad. They just are too risk averse, or it makes people too uncomfortable to think that could be life in such a foreign environment. So we includes several subsets of people. One I'm very proud to tell you is a team. I call it MIT-led international consortium, but we have partnered with Rocket Lab. They're a company in the commercial space flight industry to launch the first of its kind private mission to Venus. And our target launch date is May of 2023. And this is a small, cheap mission.
That's so soon.
It's a small, cheap mission, but we only had, it's very small. We have less than 1 kilogram for our instrument. And my job was to bring the science team and the science instrument. And what we're going to do is with our instrument is, well, first of all, I want you to imagine a rocket launching and then a cruise vehicle passing by Venus and dropping off a probe. And the probe will hurtle through the atmosphere. Won't have a parachute. It'll just go down. It'll only spend a few minutes in the clouds. And we have a special instrument that will shine an ultraviolet laser through the window of the probe. And it will light up the cloud particles. And what it's going to look for is fluorescence. If you ever go to a club at night or a kid's fun house, and how your white clothes look purple?
Yeah.
There's like, people call it black light. It's fluorescence. We're going to try to fluoresce those cloud particles. And if they do show signs of fluorescence, it means that there are organic molecules in the cloud droplets. So we won't be able to tell you there's life there with this first mission, but we'll be able to say, wow, there actually is some interesting, rich organic chemistry happening in these droplets that people once thought were sterile.
And that data will just be kind of sent back. Like the actual probe itself is going to die there.
Right. Yes,
die, I mean, in quotes, but okay.
You know what will happen to the probe? Yeah, since you asked, the probe, like a lot of bad things could happen to it. Once it gets down through the clouds, the pressure is very high in the atmosphere of Venus. And so the whole thing could implode. It could melt. Parts of it could melt, or it will crash land on the surface. So yes, It will be sending data back directly to Earth. Not too much data, but yes, it will be sending data back as it goes down.
Oh, how exciting. So I have to ask you, because I know we're starting to run a little bit low on our allotted time, and I have to ask you like a couple of things before we close out. Going back to the book, you were invited to contribute a chapter to The Sky is for Everyone. And of course, the conversation here is really about well, there's so many things, right? Egalitarianism, equity, feminism, voices, diverse voices in this field, all of the kind of blazing women that came before, the women who are doing really interesting things now. And so I'm curious, when people... I struggle to be like, oh, as a woman astronomer, like I hate that title, like as a woman scientist, as if that means anything different than just like as a scientist, as an astronomer. But of course, we're not anywhere near parity, especially in fields like physics and computer science, as you mentioned, in mathematics. And so I'm curious about your personal journey, about some of the things that you have seen change throughout your career when it comes to gender parity within this field, but also the things that you've struggled with.
Sure, I can do that. Well, I think one of the most notable things to me is in the women who came before me, many of them did not have children. Many did, but many did not. What I see coming after me is those who want to have children, because of course not everyone wants children, and that's perfectly fine. But the ones you want, people, if they want to have children, you want them to be able to have them, right? You don't want them to have to choose between their job and their kids. Yeah. So I see that. And to me, that's a huge, wonderful change. I remember when I had my 2 kids, I didn't know a lot of peers who had them. They were there, but I just didn't know about a lot of them. And so that to me is one of the best things to happen. When I came along, it was a good time, I think, kind of tricky. In my university where I was an undergraduate, there had never been a female physics professor. But that slowly started to change. Yeah, there had never been one. And that slowly started to change. And now there are lots of women. So even though there's still tough conditions, if you just want to look at the sheer numbers, some people will say it's not changing fast enough. But the fact is it has changed, even since when I was an undergrad till today. So those 2 things I told you, just looking around, that, wow, most women who want to have kids can have them now. Whereas in the past before me, you read stories, a lot of women chose. They might not say that outright, but they did. They chose a career over children. And the fact that now, before there was never a woman female physics professor, probably just not at my alma mater, but a lot of places. And now there are some. So I'd say that's a positive.
Now, now you are one.
Yeah, I am one.
and do you find that women seek you out, like as their advisor?
Yeah. I think they do, but I do try to be a role model, and I am a role model to a lot of much younger people. But I'd say the one thing that we still haven't cracked yet, not just in physics and astronomy, but a lot of places, is unconscious bias. I see that when my kids listen to me now, but there's sometimes when they don't, but you get that deep booming male voice from a much bigger male. Oh boy, they listen. And, there's some deep unconscious bias that's really there that it's really hard to shake. And even women are guilty of this bias. And that's, to me, a really huge problem. The second problem is still, there are still major confidence issues that predominantly appear to be in women. And actually, I'm trying to fix that. One of my big things I'm doing now is a big confidence program for women to help them overcome the imposter syndrome so they don't leave physics because they feel inadequate.
Oh, I love that. How important that is. make that explicit, and to sort of own it and own the psychology of it and be able to comfortably in front of your peers and in front of your colleagues say, yes, of course I struggle with imposter syndrome. And yes, of course I've been socialized throughout my entire life to feel like this isn't my path or I'm not as capable or, all these things that we know aren't true, but we're socialized to think.
Exactly. And we're socialized to never be proud of ourselves and to never internally state how great we are and how good our accomplishments are. We're somehow not allowed to do that. And that's a real problem.
What important work you're doing then, not just on the sort of quote unquote hard science, but on all of the aspects of what it means to be somebody within the field that does the science, and how can we continue to contribute to the humanism of the field, how incredibly important. So I have to ask you, because we're about to run out of time, but I love to close my episodes by asking all of my guests the same two pretty big picture questions. And of course, as somebody who thinks about the cosmos, you think big on a regular basis. So I'm curious if you don't mind taking just a quick minute to give us your thoughts on these two big questions that I'll dive into with you. All right. So when you think about the future, in whatever context feels relevant to you, this could be personal, it could be vocational, it could be global, it could be cosmic. I want to know first, what is the thing that's keeping you up the most at night, the thing you're most concerned about? Maybe you're even struggling with a bit of cynicism or pessimism. But then on the flip side of that, to end on a more positive note, where are you finding your optimism? What are you hopeful for and really, truly looking forward to?
Well, I think the thing that upsets me the most is the overpopulation of our globe. And the resources are taxed. Our planet is warming. It's not sustainable. I don't have a solution to it, but I do know that our Earth will survive. If we destroy our own human species, if we destroy our own environment and our human species tanks, then our Earth will still be around. It's not necessarily a comforting thought, but that's kind of where my mind goes on the negative. But on the positive...
Yeah, I mean, it kind of keeps you from going too dark in the hole, right? It will last even if it can no longer support us.
Right. You might not like cockroaches. I certainly don't. I've had infestations of them in my house before, but they are. Do you know how hard it is to kill them? I had to move once and sell my house, and unfortunately, we had to kill the cockroaches because you can't really sell your place when it's infested. But yeah, those things, they live. They will be here. So think of that. When I do think of the positive, I do think about the cosmos and how vast it is, and all those stars and all those planets out there, and even our own human ability to manipulate technology, not just to understand the cosmos, but to make human life better. That's what gives me hope.
Yeah. Well, Sara, gosh, it's been an absolute pleasure. I wish we had even more time to dig even deeper, but I've learned so much from you. I'm so grateful for the incredible work that you do. And I hope everybody goes out and picks up the book, The Sky is for Everyone, Women Astronomers in Their Own Words. Let us know real quick, where people can learn more about the work that you do. And if they're curious, where would you direct them to?
People can follow me on Facebook and Twitter, and they can also look at my website, saraseager.com.
Excellent. So thank you again for being here. And to everyone listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.